We'll try to get the slide presentations and get it to anybody who wants it, and also just to have future contacts with some of the questions that might be out here. And we're hoping that some of the discussions go way past this meeting and works for solving problems for the hurricane season as they come up. Again, I want to thank the Hurricane Center for sponsoring this, and of course thank our board for pushing to have this done. In talking to people who were out during the storm in South Lafourche, their estimates from 30% to 50% of the people did not evacuate. And this was a powerful storm which we could not guarantee that the levee could keep the storm surge out. Luckily for us, the system did its job, and the hurricane, which we do not control, it could have been 3 feet higher. And had it been 3 feet higher, we would have flooded. And had we flooded, we definitely would have lost minimum a couple of hundred people. Look at Devin Dodon over here with the volunteer firemen. In the middle of the storm, they had to get people who were trapped under the houses. The wind was terrible. And one of the fortunate things for us is nobody died. But they were out there helping those people out of these houses that had been blown down. Again, the water showed up. Those people could not have gotten any help and would probably have not survived the storm. So that's one of the reasons I asked Ken to come. Also, it's kind of a historic storm. It was extremely powerful, the most wind that I can remember hitting this area. And it's really important to understand how much water and wind hit each area. And it takes a while to get the most accurate information, and that's still part of the process. But coming down here and trying to exchange information so that we can get the most accurate elevations of water and the speed of the wind. And it's critical so that we can prepare for the next storm, but not just prepare physically, but prepare our people mentally to take the right action when a powerful storm starts to approach. But again, I want to thank the Hurricane Center and Ken, who was, I think, voted Weatherman of the Year. So, hey, okay, all right, very good. So, Ken, if you'd come up and start talking about what we need to hear. Thank you.
Well, the first thing I definitely want to say is, Windell, thank you for the invitation. You know, it's been hard to get out a lot of places, you know, not just dealing with hurricanes, but doing that during a pandemic is not easy. So the first thing I want to say is thank you all for what you do, because having to deal with multiple disasters and so many hurricanes and during this pandemic, just big time thank you for everything that y'all do. I know it hasn't been easy, so I definitely wanted to start off with that. So the game plan here is to do this. We're going to have Dr. Mike Brennan. Mike's going to come up and give kind of a summary of Ida. And then after we do that, I'll come back up here and I guess the best way to say it is give us some serious food for thought as we go forward. Does that sound like a plan? It's stuff, these ahas, these gotchas, whatever we call them, but it's really going to take this summary and talk about, Windell alluded to it, and how things could have been different, and small changes can make a big difference. So Mike, give us a good summary of Ida.
Adjust the microphone down a little bit here. Thanks, Ken. Thanks for the invitation, and thank you all for coming today. You know, it's really important for us to, as we go back and re-examine all of the storms, each and every storm that affects the United States and everywhere else in our area of responsibility. It's really important to get out there and be on the ground and see and talk to people affected by the event. It's a real important part of what we do, and it's important to put eyes on the areas that are affected by these storms and what happened. So what I'm going to show today is just a quick overview of Ida, just sort of a general summary of the facts and what we found so far in our analysis of the event. So, and I'll certainly thank Robbie Berg and Dan Brown, who are in the Hurricane Specialist Unit with me, who helped put this together. So, just to summarize, I'm going to try to take this out of here. Hurricane Ida made landfall as a Category 4 hurricane, basically within about 77 hours of formation. So it went basically from not being anything at all to a tropical depression to a Category 4 hurricane in just over 3 days. The Louisiana landfall was just before noon Central Time on August 29th near Port Fourchon. Our estimate of the intensity was 150 mile per hour, category 4, 130 knots, with a minimum pressure of about 930 millibars, 27.46 inches. It's important to point out that Ida is essentially tied for the 5th strongest hurricane ever to hit the United States, with just behind the 4 category 5s, Andrew, Michael.
We want to share all the information that we have and share the questions. So, thank you all for getting through this.
Could I put a live on him? That way we could at least hear.
Sure.
It's on the same frequency, Jay? Thank you. Right. Even the power out. Yeah, everything. Everything.
Now, it may be hot because I'm going to have to really talk in here.
Yeah, I've been recording the whole time.
Okay. Can you hear him?
Yeah.
Go ahead and restart here.
Summary of Ida than we anticipated here with the power out. But, you know, I'll go back to what I was talking about before. You know, it's worth pointing out that Ida is actually tied for the 5th strongest hurricane to make landfall in this country. Behind the 4 category 4s, Michael, Andrew, Camille, and the 35 Labor Day hurricane, and also tied with, you know, with Laura and several others as at 130 knots. And it's pretty striking that 3 of the 6 or 5 strongest hurricanes that hit this country have done so since 2018, if you look at Michael, Laura, and Ida. So these are pretty powerful storms. It's also the strongest storm to make landfall in Louisiana west of the mouth of the Mississippi River, tied with both Laura and the last island hurricane of 1856. In terms of observations, you know, we typically don't get a lot of wind observations in the core area where a major hurricane makes landfall. 1, there aren't that many wind observations available in general. 2, a lot of the sensors tend to fail, don't report in those extreme wind conditions. But the highest sustained wind we measured on land was in Grand Isle, the east end of Grand Isle, the Coast Guard station, 116 miles an hour. So that's a sustained 1-minute wind, which is what we're looking at for the intensity of the storm. Obviously, we had data from aircraft and other sources that suggest Ida was 130 knots or 150 miles an hour. The lowest pressure measured on land in Louisiana was at Port Fourchon, not surprisingly, right near the landfall location, about 934 millibars or 27.58 inches. Other observations that were recorded in southeastern Louisiana in terms of wind, there was 100 mile an hour sustained wind at Galliano, a gust of 122. Dulac had a 100 mile an hour sustained wind with a gust of 138. So again, not necessarily right in the core, but there was a substantial, you know, inland penetration of you know, very powerful winds with the core of Ida as it moved inland from the coast toward the New Orleans metropolitan area. In terms of storm surge, observed storm surge values in terms of water levels above mean high water or roughly above ground level, Grand Isle was 10.2 feet. Golden Meadow outside the levee was just over 10 feet at 10.1. Leeville 9.8, Port Fourchon 8.2. So we'll see a little more about storm surge, or we'll talk more about storm surge when we get to what Ken's going to present in a little while. In terms of the heaviest rainfall near Ponchatoula, we had over 15 inches. So significant rainfall, wind, and storm surge all from Ida. In terms of impacts, $75 billion worth of damage in the United States. So Ida had not only catastrophic impacts here in Louisiana, but devastating impacts up in the mid-Atlantic and Northeast states due to heavy rainfall and very significant flash flooding several days after landfall. But the combined total of that damage, $75 billion, more than all the damage from all the 2020 tropical storms and hurricanes that hit the United States, just from one storm. In terms of fatalities, we had 4 direct fatalities in Louisiana directly due to the causes of the storm, 1 from storm surge, 1 from freshwater flooding, and 2 from wind. It's a pretty remarkably low number for such a catastrophic hurricane. Now, there were 26 indirect fatalities, though, in Louisiana. Again, these are fatalities that generally occur after the storm. Most of them were due to heat-related fatalities. There were 13 of those. 6 from carbon monoxide poisoning from improper generator use, which is an increasing cause of indirect fatalities we've seen in recent years. 5 medical incidents, and then a couple of others. So we're seeing this trend towards an increasing number of indirect deaths in the very hardest hit areas where people are left without power, infrastructure, emergency services, medical care, even though we're in recent years been able to keep the direct deaths in the immediate landfall area pretty low. So I want to take you through the timeline of what we were seeing at the Hurricane Center even back to before Ida formed. 4.5 to 6.5 days before landfall, we first mentioned Ida in the Tropical Weather Outlook, which is our product that tells you, comes out every 6 hours. It tells you what are the chances we could see a tropical cyclone form somewhere in the next 5 days. First happened very early in the morning on August 23rd. So about more than 6 days before landfall, we were highlighting an area in the Western Caribbean just to the north of Central America, east of the Yucatan Peninsula. Say, this is an area where we could see a system form in the next few days. First with a low chance, we raised that to medium 12 hours later, early in the afternoon on the 23rd, and then raised it to high the morning of the 25th. So just at 1 a.m. Central Time on the 25th. That's where we were very confident that we were going to get some type of tropical cyclone forming either in the northwestern Caribbean, near the Yucatan Peninsula, or the extreme southeastern Gulf of Mexico. So we're able to hone in on the fact that we're expecting a system to form. We were also seeing signs that it was going to be a significant system. We started putting out our key messages, which are really these sort of high-level talking points where we really try to focus in on the hazards associated with the storm or even something that hasn't formed yet. So 4 days before landfall, before we even have a tropical depression, we're talking about the potential for dangerous storm surge, wind, and heavy rainfall impacts for Louisiana, Texas, and northern Mexico. That time range, there was enough uncertainty. We weren't sure what part of the sort of western and central Gulf Coast Ida might affect, but we were confident it was going to be somewhere between northern Mexico and Louisiana. And that was around early afternoon on the 25th. By the next morning, on the 26th, we were really starting to highlight the specific greatest risk right along the Louisiana coast. We'd seen some trends in the model guidance, what we were looking at. We were more confident that those significant impacts in terms of surge, rainfall, and wind were going to be on the Louisiana coast early in the morning of the 26th. And then we started advisories on the system as a tropical depression just a couple hours later. And that initial forecast, we had a 35 mile per hour tropical depression. And in 72 hours, our forecast, the forecast that Dan actually made, was to forecast a 110 mile an hour hurricane, basically right off the coast of Louisiana in 72 hours. It's one of the most aggressive initial intensity forecasts that the Hurricane Center probably ever made. To show that sort of confidence, and we were confident because we were seeing signs in the hurricane models and the global models and our assessment of the environment that Ida was probably going to rapidly intensify from its early stages all the way up to landfall. And so we were essentially showing something right at the cusp of major hurricane strength, right off the coast of Louisiana within 3 days. And again, we were explicitly forecasting rapid intensification between 48 and 72 hours. So we were pretty confident that most of that strengthening was going to happen in the last 24 hours before landfall, which is really challenging because if you don't project that, then people are going to be making decisions, based on a forecast of a potentially weaker system, might not take the right levels of preparedness. But again, we were very much at the top end of the intensity guidance to go out there with that confident forecast. And because it's that first forecast, people tend to make decisions. They tend to anchor to that first information they hear about a storm. So right off the bat, we were able to tell people this is going to be a significant hurricane with multiple life-threatening hazards. And we were mentioning, again, in our key messages that the depression was going to become a tropical storm and eventually a hurricane would approach the northern Gulf Coast at or near major hurricane intensity Sunday with life-threatening storm surge, damaging hurricane-force winds, and heavy rainfall with the greatest risk along the coast of Louisiana. And then about 2.5 days before landfall, so now on the 26th of August, that night at 10 p.m. Central Time is when we put out a hurricane watch for the Louisiana coast, including the metropolitan New Orleans area, Lake Pontchartrain, Lake Maurepas, as well as a storm surge watch for much of the Louisiana coast. Again, showing that the possibility of that life-threatening storm surge inundation, the possibility of those hurricane-force winds within about 48 to 60 hours. So those are timed to the arrival of sustained tropical storm-force winds when those hazards are really going to start. And we actually issued those watches a little early in coordination with the Weather Forecast Office in Slidell. The confidence was there. We knew it was a significant enough threat that we could have waited until 4 o'clock the next morning, but we decided to do it early, give people that additional lead time because it was such a significant system. Again, we started messaging the potential for 7 to 11 feet of storm surge inundation along portions of the coast of Louisiana, 7 to 11 feet above ground level, potentially devastating wind damage near where the core moves on shore in that eye wall. And the risk of hurricane force winds is essentially increasing for the Louisiana coast and the New Orleans area. Now, about 18 hours later, the afternoon of the 27th, essentially a little less than 48 hours before landfall is when we had the hurricane warning and storm surge warning issued. Now we're talking about the danger of those hazardous, life-threatening hazards from both the hurricane force winds and the storm surge identified for much of the Louisiana coastline. Now we're messaging 10 to 15 feet of life-threatening inundation. Now we're forecasting Ida to become a Category 4 hurricane before landfall with potentially catastrophic wind damage. That's what Category 4 means, potentially catastrophic wind damage at those very highest winds and where that eye wall comes on shore. And hurricane force winds expected to move inland near the center of Ida into portions of southern Louisiana and including metropolitan New Orleans. And the consistency of that forecast, of that Category 4 major hurricane is really important. And we stuck with that forecast. Even the day before landfall, Ida's intensity increased really quickly that first day, and then it sort of leveled off for about a day. And Dan was working the forecast that day, and some of the intensity guidance started to back down a little bit from that Category 4 prediction, but we stuck with that in the NHC official forecast. The consistency of the messaging there was very important. So we maintained that Category 4 forecast all the way up through landfall. And then the day before, now we're really starting to highlight, essentially the life-threatening inundation is starting to hone in now in the area between Morgan City and the Mississippi coastline, more than 9 feet above ground level. Potentially catastrophic wind damage where the core of Ida moves on shore. Hurricane force winds now expected well into the metro New Orleans area, and then also the damaging winds spreading well inland, especially the high wind gusts causing widespread tree damage and power outages across much of southeastern Louisiana. And then unfortunately, we did see what Ida was predicted to do from the very start. In the 10-hour period from 10 p.m. on the 28th of August to 8 a.m. on the 29th of August, Ida intensified from 105 mile an hour to 150 miles an hour. So we saw that very extreme rapid intensification there in that last night before Ida made landfall. And again, those highest winds are going to be right in that eye wall. And as the eye moved on shore near Port Fourchon, the areas just to the east of that on the eastern eye wall are those areas that got those very highest Category 4 sustained winds. But again, hurricane's not a point. That wind field extends out well to the east of the center, not just the sustained winds, but the wind gusts. And those gusts tend to do a lot of the damage as well. And we saw a lot of that damage today as we drove down to Grand Isle, Port Fourchon, and even here across much of Lafourche Parish. The NHC track forecasts were very consistent in showing a hurricane making landfall in Louisiana from the very first forecast. Forecast after forecast after forecast showed that consistency, and they were also very consistent in maintaining that threat of a major hurricane from the very first advisory onward, all the way up to landfall. So that consistency of messaging is something we really strive for because we realize people are making life or death decisions about evacuations, about planning, preparations, and we want to maintain that forecast as consistently as we can. That's a big role of the human in the forecast process. The models can bounce around, they can do whatever they want. They don't have any kind of conscience. They don't have any kind of role in public messaging. It's the human forecaster that takes all that model data, takes their analysis of the understanding of the situation and turns that into a forecast product that's usable for people to protect their lives and property. And that's sort of my quick overview of Ida. I can turn it over to Ken, and he can cover some of his other points he wants to make about the hurricane messaging in general and talk a little bit about forecast uncertainty.
Thanks, Mike. Appreciate it. And once I go through my part, we'll definitely have some time for a little Q&A. it's just a perfect opportunity for us to have some of these discussions. And you got the experts here. I mean, you got, Mike is he's the branch chief of the hurricane specialists. There's only 9 of them, and there's 1 Navy person at the office. I'm just going to make the statement right here and now. They're the best hurricane forecasters on earth. We got others here. Dan Brown back in the blue there. He's our warning coordination meteorologist from the Hurricane Center. He issued your Ida forecast. He was the one that issued that first forecast, the boldest forecast in Hurricane Center history. That was Dan. And Dan, if you'll share, not now, but during the thing, Dan and I were talking in the back, and that's an emotional thing in itself. Can you imagine going out on the limb and then you don't hope it happens, right? But you don't want to false alarm people. So it's a tough thing, even as a meteorologist, to go on the limb like that. It's pretty interesting. And we got Robbie Berg here. He's hurricane specialist and our social science expert as well. Most people don't know that all of our products, most of them anyway, are vetted through social science. They have to be understood or they don't do any good. So we run that stuff through social science as well. We got Jamie Rhome here. He's our new deputy director, and for many years was our storm surge expert. He ran the storm surge. And we got Cody Fritz here. He's handling the storm surge duties, and he worked Ida. He was the storm surge forecaster during Ida, which wasn't easy. That was not your first rodeo, but pretty on solo anyway. So you got the experts here. So afterwards, let's definitely talk about some of the questions and think about things on your mind. Anybody want to put their hands up? Has it been busy? Yeah, of course, silly question. But what you're going to see in this presentation is it's not just opinion, it's not just random ideas. We take the science and history and turn it into things that we need to know. These are real considerations. These are the things that we have to have the tough conversations. We have to have really think about the things that'll burn you in the heat of the battle. Does that make sense? So it has been busy. It's not just what you feel. It's really, and you do feel it. Historically, it's interesting. Think about this for a second. More category 4 and 5 landfalls in this country from 2017 to 2021 than we have from 1963 to 2016. And you're going to see a lot of pauses here because some of these things need to be really driven home. It's busy. Bottom line, the data really shows how busy it's been. $420 billion worth of damage since 2017. Ida was a big chunk of that. I mean, think about this, $75.25 billion in Ida alone. We've had $15 billion storms during that period of time. Yeah, it's been busy. It really has been busy, and Louisiana's really taken a big hit from this. Here are some points we got to drive home. These are important. Hurricanes don't care about your timelines. You know, we have a lot of timelines, 5 days, 7 days, 10 days. And as Mike put so out there, you look at the timeline of Ida, it seems quick, right? That's not the rare thing. It's actually pretty common. We looked at some interesting data here. There's only been 4 Category 5 storms to hit this country on record. We've got the Labor Day storm, Camille, Andrew, and Michael. There's only been 4 of them. They were all tropical storms 3 days prior. So we dug a little deeper. Think about the timelines. We looked at every storm that was 150 miles per hour or greater. 9 of them. Take this in. Out of the strongest storms, last 100 years, every storm that's hit this country 150 miles per hour or greater. In other words, the nation's strongest storms, every one of them was a tropical storm or less 3 days prior. But in our minds, we think they're going across the Atlantic. You got lots of notice and all that thing. The biggest storms in this country, you don't have that kind of notice. It's not the way it works. They're fast. Does that make sense? So as we're working our 5-day plans and our 7-day plans plus, the reality is the nation's strongest storms, you got 3 days or less. That's the norm. And y'all jump in any time if I mess stuff up. But that right there is, that's pretty sobering.
if you ask me. In the last, I'm going to repeat it, last 100 years, every storm that's hit this country 150 miles per hour or greater was a tropical storm in the last 3 days prior. The average, you take those 9 strongest storms, the average of those storms becoming a hurricane, 50 hours prior. You got to take that in as we go forward, okay? So it's kind of interesting to look at some of that data. Hurricanes do not care about your timeline whatsoever. The next big point we have to talk about, this is really important because everybody has an opinion after these storms that it didn't happen last time, or it's so dangerous to compare storms, and this is why. Little wiggles matter. Little wiggles matter. It's incredibly important to have this conversation. And really looking at some of the storms in the past, you look at Hurricane Laura. If Hurricane Laura was 20 miles to the west, 20 miles to the west, Hurricane Laura, 20 miles to the west. So I just moved the track 20 miles. That made a difference in 10 to 15 feet of storm surge in Lake Charles. And we talked about it earlier today. We were talking about the average error 24 hours out, 35, 40 miles? Think about that. Little wiggle. That thing moves around 30, 40 miles, 24 hours out. Still a good forecast from a science perspective. It's going to do that. But 20 miles can make a giant difference, and that's what would have happened in Hurricane Laura. That's a big difference. Y'all agree? I mean, that's just a little wiggle. And that's why when we issue the forecast, whether it's storm surge, we try to take a probabilistic approach. Afterwards, I can tell you what happened. You can too. But we got to do it days ahead of time to make sure we get people out of harm's way. So we take a probabilistic approach. We throw everything at that hurricane, bigger, smaller, faster, slower, left, right. We throw everything at it, and that's how we come up with your storm surge forecast. Because we're not going to risk lives on little wiggles, right? So that's how we calculate that difference. Here's another thing that we have to talk about. I look at Ida, wiggling around, wobbling around. Those wobbles are pretty normal. You look at the forecast 12 hours out, 24 hours out, very little difference in the actual location of the storm. Just look at the data. You got those little wiggles, but here's what we always got to remember. This is really important. We have to be very careful shaving the line of winds too tight. Let me explain. I think, Windell, you can help me through this too. We're all good at knowing the center wobbles around, right? We understand that. They wiggle and wobble. That's a normal part of a hurricane. You have to do this as well. We have the radius of winds, where the hurricane force is going to wind. You can't do this, and that happened a little bit in Ida. We wobbled the center around, but not necessarily where the radius of winds were. This is how it works. So if that center shifts, that's going to move your hurricane force winds outside on the outside radii. That's going to move your rain. That's going to change things. Does that make sense? It's really important because you look at graphics, you see things, and everything looks so accurate ahead of time, right? You look at a graphic, and that's what's going to happen 2 days from now. Please be careful. Does that make sense? If that center's moving, and you're in a parish and saying, I'm outside those hurricane force winds, that's not how it works. That's a little dramatic, but it's real. Please don't cut that too tight, because that center moves, everything else is going to move too. Does that make sense? Okay. We talked about throwing everything at the model. Structure matters. If the storm slows down, you got more storm surge and prolonged winds, more damage. Left, right, we just talked about that. The storm gets bigger, more storm surge. Slows down, more storm surge. Little changes in that structure of that storm can make a big difference on the ground. Okay? Small changes can make a really huge difference. So brand new information. So this is part of it. We've heard things like this is, worst case scenario. This is as bad as it gets. And as a group of meteorologists here, a meteorologist can always make things worse. We can take the moon out of orbit if we have to. I joke about it, but it's true. We can really make things worse. We ran some scenarios, and I'll try it here and see if Cody can jump in, or Windell, you can jump in. We ran, remember how we just did the Laura example with 20 miles? We did the same thing with Ida. So what we did was we had an alternate track of 15 miles for Hurricane Ida. What's our error at 24 hours? 35, 40 miles, right? 15's a little wiggle. 15's very realistic. 15 miles to the east, and we wanted to see what would happen. What happened was very interesting. We saw, in this case, the New Orleans West Bank area, 5 to 7 feet of additional storm surge. It overtopped the levees. 15 miles. Not that much, right? We looked at some other things, and then I'll see if I missed anything. We also took the same track of Ida and made it larger, just a larger storm. And I think, what were the values for here?
Additional 3 feet.
3 feet. How high did the water get on your levee?
30% was within a foot of the top of the levee.
What would happen if we had 3 feet?
Not good.
All I did was make the storm a little bigger. This is stuff we got to talk about. When we talk about evacuations, you talk about social science and perceptions of a storm afterwards, right? Everyone's got their perception. We got through it, got through the big one, I'm good. I could change that really quickly by either moving the storm or, in this case, just making it a little bigger. Take it in, bigger storm, additional 3 foot on yours, and you start filling inside the levees. Windell, Cody, did I miss anything on that? Okay. Something to take in. I'm going to pause a little bit and see the reactions. Anybody surprised? A little bit, huh? Yeah, that's why we really do like to travel after these storms and have these conversations. Okay. All right. We talked about it before a little bit. Every storm's so different. This is a fact. The Hurricane Center, we share all of our errors. They're public. If storms we do well on, storms that were a little more challenging, we share all of our errors. And this is a fact over the years. It's interesting. As the intensity increases, our average error goes down. In other words, our track error is better for stronger storms. The weaker ones are tougher. You got centers jumping around. We're sending aircraft out there, and you got center. A little 10, 20 mile reformation of that center could mean a 50, 60 mile difference down the road. Does that make sense? Little changes at the beginning can make a big difference on the other end. So remember, every one of these are so different. I mean, think about the consistency of the Ida forecast. You think about the consistency of the Laura forecast. Remember Sally? Moving really slow, jumping around a little bit. Louisiana, then Mississippi, and then pretty soon Alabama and all the way over. That's going to happen. So remember, you look at our accuracy, it's going to increase with some of these stronger storms. Some of the weaker ones are tougher. They're tougher on us. Something to consider. And I will say, and Mike, you can help me through this a little bit. You really look at, Mike alluded to it in his presentation, some of the earliest model data with Ida. If you go back 3 days before the forecast, 2 days before the forecast, most of the models were taking the system to Texas. And Mike used the word anchoring, and Robbie with the social science background, if that first forecast went to Texas, how hard is it to get the public to realize it's coming here after that first forecast goes to Texas? That's tough. From a psychological perspective, that is tough to bring it back. Okay, so some of the earliest models were taking it over there. So if you think about that forecast, the leap to issue that first forecast for Ida was incredibly aggressive on our part to be able to get that first forecast out. Those models were all 2 days prior. They were all looking at Texas a couple days prior. So it's something to think about when you look at the data. And you got general public. You got your public looking at those models saying, it's going to be somewhere else. And that could be a problem. As you look at it. I'm going to have some data here in a second to really support that. Okay. Here's the other one we have to have a conversation about. Indirect versus direct fatalities. Traditionally, storm surge has been the leading cause of fatalities from these tropical systems, 50% of them, historically. 25% of those fatalities is the rainfall. In other words, about 75% of your fatalities, it's water. The wind's dangerous, absolutely, it could be life-threatening. Water's what traditionally is killing people. We implemented in 2017 the storm surge watch and warning. We got inundation mapping. We're reducing those numbers. We're making a dent in those storm surge fatalities. We really are. We lost more people to storm surge in Hurricane Sandy than we have from all of these hurricanes that I talked about from 2017 to 2021. Take that in. We're making a dent. We're reducing the fatalities. I think I got it correct, I hope. Making a dent in it, okay? We got to remember the indirect fatalities. It's not just about that water. It's not just about that initial hit. It's no fun afterwards, is it? It's rough afterwards. And if you think about Hurricane Ida, Mike mentioned we lost 4 people directly in southeast Louisiana, which is 4 too many. We lost 47 people in the northeast U.S. That far away. That happened in Camille. That happens with some of the larger ones. You have a big impact well inland. We see that all the time. However, there are 26 indirect fatalities in Louisiana and 4 in the northeast. See what happens? So we may be able to reduce those fatalities in the initial part of it, but it's rough afterwards. It's rough, no power, danger, all the dangers associated with the debris, and you can lose the generators. We just got to work together to keep spreading the word to keep people safe from these generators afterwards. People, losing their lives because of carbon monoxide poisoning. So it's interesting to talk about. Here's one I want to talk about that I think is important. I'll just make this point. There's models out there. They're available on your phone. You can see the different models, the European, the American model. We have all this. Your public's looking at that. Everybody's looking at every single model. But I just want to say it this way. At the Hurricane Center, our forecast, we beat any individual model every single time. There's value in these smart, the whole building's smarter than I am, by the way, at the Hurricane Center. They're brilliant people. There's a reason we have humans involved with this, so you don't have to worry about it. We beat any of those models every single time, the value of the human being. We looked at it every different way. And it's not just the accuracy of the track, and not just the accuracy of the intensity, it's more consistent. Can you imagine if we windshield wiper it all over the place? Homa, not Homa. Homa, not Homa. Can you imagine? How do you make a decision on that? So it's not just more accurate or more consistent, okay? So the models can do things like this, but the human can interpret that and keep it where it's supposed to be. That's important. There's enough stress in these storms not to go chasing things down to find other solutions. We beat them every single time, okay? The other one is, I don't know if you've heard of this, the Weather Prediction Center puts out an excessive rainfall outlook. It's really important for flooding. What's the leading cause of fatalities in these things? Water, okay? So we have an excessive rainfall outlook. Remember, little wiggles matter. When you look at a chart and say, in Lafourche Parish, we're gonna get 6 inches from this storm. That's a snapshot based on that forecast. If I move that forecast, what could happen? You could get 20. I heard 20 over here. Or you get 2. Right? And the interpretation of somebody looking at that is like, well, you blew it. There's a lot more rain. Or the other person is like, it didn't happen. Right? Remember, it's so important. There's products for this. Please be familiar with all the probabilistic products. When there's a high risk of flash flooding that's issued from the Weather Prediction Center, that means something, right? That's taken into account those little wiggles for the most part. So the reality is, we've talked about this a couple other parishes. When there's a moderate risk, we don't get highs down here too much. With a moderate risk of tornadoes and severe weather, what do we do? What do we do with that? We activate, don't we? I've seen schools canceled. Moderate risk. I look at some of the parishes, moderate risk, we close schools, we activate the EOCs, we get things into gear. What do we do for a high risk of flash flooding? Be honest, it's okay. It's not the same, okay? So if flooding is the leading cause of fatalities, we need the same reaction from a high risk of flash flooding as we do even severe weather. These are things we got to talk about. Okay. So getting into it, just a couple, I wanted to talk about this real quick. With so much social media, there's so much information out there, words matter. They really matter. Anybody remember in Hurricane Laura when we used the terms unsurvivable? Yeah, that was a conscious decision to get folks out, right? That was a conscious decision. If you're forecasting 15 to 20 feet of storm surge, that's unsurvivable, okay? It helps with social media. It helps us you can't do that all the time, because if it doesn't happen, they're not going to listen next time. But there's words matter and what words we use, and that's why we spend time with the briefings. That's why we spend so much time on social media. We're very aggressive with the social media. We're aggressive getting the information out, and that's because we want to try to control the message. This is important too. We've had so many large hurricanes. I talked about it, the 2017 to 2021, that there may be a tendency to only ramp up for the big ones. Remember, there's no such thing as just a tropical storm. There's no such thing as just a Cat 1. It's still about those impacts. Remember Hurricane Isaac? Category 1, barely. 12, 13 foot storm surge, catastrophic rainfall. So we got to make sure as us, the public, that there's no such thing as just because it's not as strong as Ida doesn't mean you wouldn't have a big impact. Does that make sense? So we got to be careful of that going forward, because sometimes there's a tendency to let our guard down with some of the lower categories, when in fact you can get tons of rain, tons of storm surge. It's all about those impacts. So really listen to our impacts when we put those out there. I think those are the big ones that I had. The last one I had was just a pet peeve that I'll end on this. Just let's all be careful using the term fish storm, because last year as of October 12th, 2021, we lost 122 people in the surf zone, rip currents. So just because the storm's well offshore doesn't mean you can have dangers along the coastline. So please pay attention, marine forecasts, pay attention to those rip current warnings and that sort of thing, depending on where you are in the country. So just because it's a distant storm doesn't mean it's not dangerous. Okay, so that's really the stuff I wanted to get out. You didn't miss anything from the graphics. This worked out perfect, meant to be. This was absolutely perfect. Now's an opportunity to ask questions and think about it. I would love to start things off by asking anybody to volunteer. What was your any aha moments in either presentation? Anything that really struck you from this presentation? I'd love to hear some feedback on that. Anybody dare to go first?
I might ask a question a little bit beyond the presentation. I'm a northerner, I live in Baton Rouge. So, compared to this guy down here. So I deal with, we know each other. I deal with real situations, and all that. But in terms of this talk about changing the weather, the temperature rise, et cetera, I'm not a fan of that concept, but nevertheless, assume that's correct. The scientists say, well, it's going to rise 2 degrees, 3 degrees, Fahrenheit, centigrade in the next 30 years. What impact, if that is correct, what does that mean in terms of the intensity of the storms? Are they going to rise, as the temperature rises, are they going to become more intense? Because heat is what drives them, the way I understand it. So it starts somewhere in Africa, in the western part of Africa, and so on and so forth. So does that will impact the intensity, in other words, the intensity, generally speaking, of the hurricane?
No, it's a good question, and it's interesting when you look at some of the data, and you're all going to jump in here too. I think we're not really seeing anything really significant in the number of storms, so we're not really seeing any changes there. We're seeing, I can tell you, there's been more rapid intensification in the Gulf of Mexico. That's something that's been interesting to watch, but there's some correlation with stronger storms, but I think the greatest correlation that we've seen is just the physics of the atmosphere. A warmer atmosphere holds more water. So if the atmosphere holds more water, what do you think that's going to do to our rainfall rates? They're going to increase significantly. So I think one of the big correlations that we've seen is you're going to have heavier rainfall events. You're going to see heavier rain from some of these. And I think the other one to realize with, you can see a northward progression of some of this tropical activity. Up the East Coast, you're going to see, as a warmer atmosphere, you can see a further north progression of some of these storms and impacts further north, and the rainfall too. You're going to see some of that. Any opinions from this group?
You're
Robbie?
going to see greater
Oh.
storm surge.
The storm surge part of it, I think, is big. You got higher sea level. What that's going to do, you're going to have more water to work with. So, you can see, so two things. I think you can see greater storm surge, but the thing that I've always said, Cody, you and I have talked about this, I think you could see a further inland extent to some of that storm surge.
Yep.
So if you got more water to work with, it can sneak in more nooks and crannies, so to speak, further north. So I think that's another impact that we're going to see. So we really deal with what are those impacts. So this is what's happening from a climate standpoint. What are going to be the impacts on the ground? Robbie, do you have anything?
Yeah, I was going to mention too that some of the climate research is showing that storms are moving more slowly because the steering patterns that push them around are weakening.
Yep.
That will lead to greater storm surge, more inland penetration,
Rain.
heavier rains, and over a longer period of time over areas. So slow storms are not good
Yeah.
for multiple reasons.
Yeah, and the other thing that future climate modeling is looking at, and this is still an area of active research, so it's certainly not settled, but the best information we have now suggests that in future climate scenarios, the overall percentage of Category 4 and 5 hurricanes will actually go up. There might be fewer hurricanes overall, but we're still probably going to have the same number of the very strongest hurricanes. So, it's not just warming the sea surface temperature, it's what happens elsewhere in the atmosphere, and that can control how strong storms get. So, but those changes are going to be really small. And our ability to even analyze how strong a storm is right now, say with Ida, is about plus or minus 10%. So if we have a 150 mile an hour hurricane, it could be 135 miles an hour, it could be 165 miles an hour. Those uncertainty bounds are bigger than any sort of intensity trend we might see under some of the future climate scenarios. So I think it's wiser to focus on the sea level rise, increasing the storm surge risk, and the potential for the heavier rainfall, and really focus on the hazards, because that's what really matters.
Yes, ma'am.
Yeah, I think a message that I've heard from you that we need to try to reinforce with people is it's easy for people to say, we survived Hurricane Ida or whatever hurricane, and then use that as their baseline for assessing their risk for other storms. And I think the point that you made earlier, that each storm is unique, a different angle of approach, different intensity, different speed. People really need to understand that. Just because we survived this one doesn't mean we'll survive the next one.
Can't compare
with the same
storms.
level of damage.
Yeah, you can't compare storms. I think about today what I did with the 15 miles of Ida and the 20 miles of Laura. The public needs to see that. Because if they're in a place that, wow, that didn't happen, you could be risking your life if you don't leave based on 20 miles, 15 miles. And remember our average error? A day out. Anything within 35, 40 miles, from a science perspective, is a good forecast.
I think people tend to, I survived a strong Cat 4.
Yeah.
I'm okay.
It's important to note that those strong Cat 4 winds occur over a very, very small area, maybe just a couple miles in the eye wall, right where the eye wall crosses the coast. So that area on the east side, we had the landfall at Port Fourchon, just east of there in that eye wall. I can't show you the radar picture, but where that eye wall is where those very strongest winds are going to be, but they're only going to be there in that one spot. The potential is for them to occur over a pretty wide area given the uncertainty in the track, but that does color people's perceptions of what they survived, when in reality they might have only gotten Category 1 or 2 winds if they were 20 or 30 miles on either side. But they think, oh, I survived Category 4, even though that's not what they might have experienced at their house.
Well, we kind of talked about that.
Yeah.
About getting an image in the future where you show exactly where Category 1 winds pass and Category 2. I think we got the tools to do it. You have to be exact, but a good example is, again, I mentioned Katrina. The back side of the eye is hitting Grand Isle. We're 16 miles west, and we're getting maybe a Category 2, and then just another 20 miles in terrible, and then we're getting barely a Category 1. And yet, people felt some wind and said, oh, a Category 3 storm in Katrina. And I think that's one way to get to the public, is we show, take the most powerful storm and show where if you were in, let's say, Curole, you just had a category 1, even though you were dealing with a category 5 storm. That's one way to do it.
Or if you're 70 miles away and my trash cans blew over, I got through Ida. No, you didn't. But that points to it. That happens because I've been in those areas where people say that. Yeah.
Don't you think something, an image like that would counteract your social science drive to make people want to be more cautious and getting away from a storm?
Well, you wouldn't do that in a forecast sense, right?
Right, no, but, well, I mean, even in a retrospect image, if you know, because I mean, I stayed at my house with cut off for the storm, and I mean, I can't tell you how fast the winds were, but, I mean, I think from a retrospective, if you tell me, well, you had category 1 winds at your house in cut off, which I think it was much more than that, but, then I would say, oh, well, you know, hell, well, I'm gonna stick it out again, which in my mind right now, I wouldn't stick it out again.
Well, but that's the point.
Yeah. That's right.
Ties to the wind you had at the spot. Sure. So the wind where you were, in all probability, was very close to 4, okay? Right. And that's where it come up. But the guy in Terrebonne, who might have got winds of 100 miles an hour, thought he was in a category 4, okay? And so that's the point, because I think it actually works with it. I also thought about doing a program, taking the most powerful storm of the previous year and then put it on a track at another place and name it wrong storm, right storm, wrong place. And so people understand what their risk is in their area. In fact, I was working with a group to try to get Hurricane Laura and put it on the critical path for our levee system in South Florida. And we pretty much got it.
Yeah.
But actually what Ida did. So there's some ideas that I've thought about in again, dealing with emergency preparedness and flood protection together. So let's at least let people think through that exercise of that happening.
Yeah.
You said this was the 5th most powerful storm to hit the United States behind the category 5. What comparison did this storm have as far as onshore motion, as far as these other storms? So in my opinion, I mean, this thing took forever to get from Tucson to my house in Curole, which is 35 miles. And it just seemed like it took forever. I mean, it was, you know, at 9 o'clock in the morning, I was outside trying to secure a fence, and then within 45 minutes, I couldn't be outside my house. And it seemed like at 8 o'clock that night, when I finally decided I'm gonna venture out and try to turn on my generator, and there was still sheet metal flying around my door, it seemed like it took forever. So I don't know in comparison to other storms, so Katrina, Andrew, different things like that. Was this, I mean, it kind of, in my opinion, it seemed like it hit a brick wall when it hit land, and it just stayed here forever.
Yeah.
It was certainly moving slower than Katrina, Andrew, even Gustav, I think, was moving faster. So it certainly was a slow moving storm, and it was fairly large too. So that contributed to the length of time you had damaging winds.
And also you had a turning track. You had a storm that was sort of going from a northwest motion and turning northward. So even, you know, as it makes that turn, it sort of
slows down.
The right side of it sort of slows down and stays stuck over the same area. And we did see a slowdown, especially right after landfall in the first 6 hours or so. The storms tended to sort of stall out a little bit. But those are, again, sort of in the noise of what we can forecast track-wise. But you know, but that duration does matter in terms of the wind damage, in terms of the rainfall, and in terms of the storm surge.
And we had in that, exactly what you're talking about, we had that worst part of the storm the entire time. So
right, you were on the east
it
side.
It wasn't just slowing down, we had the whole
Hit the right side. Yeah, you did.
My parents
You
lived
did.
20 miles up the road, and my dad was able to call me and said, "Oh, I'm in my yard cleaning stuff up," and I never saw the eye pass over my house. I stayed in the eye wall.
You stayed in it.
You know, I told him, I said, "You need to get back in your house because the back end of this thing is almost even worse than the front end." And you know, but and like I said, he lived right at Highway 90, and I think he kind of took a jog more towards New Orleans, almost at the Highway 90 area. It just seemed like it took forever.
Yeah.
Yeah, well, I was here for 5, but I was also here for Zeta last year, and Zeta was struck right through.
Yeah.
45 minutes.
They're all different. They're all different.
Going really quick and going really slow, make all the difference as far as I'm concerned, with damage and all the other factors.
Yeah. It really makes a difference. They're all so completely, they're all different. That's why the dangers of comparing storms, you can't compare those two. in the general public because there's different characteristics. You know.
So when we flew over this area for right after Ida, we saw evidence that the center of the eye came between Galliano Cutoff and Ocean. So right in the marsh between it, Catfish Lake. We saw evidence of overtopping near Pontiac from inside to out, and closer to Cutoff near the Apache Farm from outside to in. So that's where you're counterclockwise. You can see the very center of the new Grand Bayou floodgate. It was almost the center of the eye. And then after it came above the road and crossed Bayou Touche about around Valentine, turned, north.
So while you kind of focus over, so I think I heard you say, at some point during the presentation, I think I heard you say that we had a pretty good track record of these strong storms forming quickly, like from 50 hours from nothing to a pretty severe storm. I think one of the presenters said that earlier. I don't know if I'm reciting that correctly.
Yeah, the stronger storms have a better track record for accuracy than ones that are just forming. So ones that are, the center's bouncing around, Sally, or ones that are just starting to form. If you don't have a center, the models don't know what to track. In other words, yeah.
He's talking about the lead time.
Oh.
I think you made a comment about that some of these stronger storms have really developed very quickly in terms of intensity. I think that was a comment I heard from somebody earlier.
Yeah,
which
yeah.
Probably for everybody in this room, everybody kind of took a step back and said, well, that ain't good. Because,
yeah.
Right. Storms tend to undergo rapid intensification early in their life cycle as a tropical cyclone. So most of that really rapid intensification happens within the first 2 or 3 days of formation. And that's what it really takes to get up to that high-end Cat 4, Cat 5, is you have to have one of these rapid intensification episodes. And so that's when a storm's going to tend to do that. So if a storm forms far away from you, it may do that way away from you, and it could still come your way later on, but it's probably going to have weakened by that point or gone some structural changes. So, but these very strongest storms that make landfall in the U.S. are typically forming very close and rapidly strengthening up to or right up to landfall. And that's how they get to be that strong.
Yeah, so again, that doesn't make me feel good at all. Okay, but the second part does, because apparently, if we watch a storm that forms a good ways away from us, there's probably a less chance that it's going to be a severe storm. Again, I'm interpreting what y'all are saying. I'm certainly not a forecaster by any stretch.
Yeah,
you could say it probably
I'm not have a storm form in Cuba and watch it for a week. That's going to make us feel better. It's going to be less intense.
Potentially from a peak wind perspective, but you can have a Katrina form and go across Florida and make landfall and be big and slow and an Isaac.
Or an Isaac type of thing where
it's not an all clear.
It's not
Y'all not helping very strong. A silver lining in
I know.
In water
Yeah, I know.
temperature too, though. So right before
Yeah.
we get to the coast, the water temperature might have.
Yeah, it's warm.
Well, we tended to.
Yeah.
Question here. I heard the news talking about microbursts and spin-off tornadoes, and there's so much evidence of something happening. One neighborhood is knocked off completely, and then 2 houses over nothing, and then 4 houses over another tornado. Can you explain what happens there?
Yeah, I mean, within that hurricane, there's a couple things going on. One, outside the center, especially if you look out, it could be 100 miles away. You can get tornadoes come on shore. So you can get all sorts of tornadoes associated with these hurricanes. The other part of this is even around the eye wall, all sorts of spins. So 2 things going on. One, you could have a vortice hit a place and not another place. But there's another thing going on too. Not all structures are built the same. So you got everything from building codes to structures that are built out of one type of material and a different. You can have one survive and the other one not. It's complicated when you really look at the damage. It could be a vortice, or it could be the difference in construction. So you have a lot of different things going on at the same time associated with looking at the damage afterwards. Yeah.
And I was going to go back real quick to the earlier point. One silver lining that I think we do have is that the forecast, at least for formation and for rapid intensification, have gotten a little bit better. We still have a ways to go, but a forecast like we made for Ida, I don't think we would have made it more than 5 years ago. And just the messaging that we were able to start doing even before it formed, that we were starting to hone in on, impacts several days away for portions of Texas, Louisiana. again, that's the silver lining here, that we're seeing some improvements in the science to let us be able to do that type of messaging and those forecasts.
I don't think you would have got that forecast 5 years ago. Mike, I don't think the confidence would have been there. And Mike, you mentioned it, and I'm going to steal it from now on too, but we've cut the intensity errors in half. What'd you say, last 5 years?
For rapid
That's a silver lining. We have more confidence in forecasting these type of storms that we didn't have before. That's a huge leap in the science. The science keeps getting better, but we got to have as the science gets better, the forecast gets better. These other conversations has become that much more important about the lead times, that much more important about the impacts, that much more important about the things that we talked about today. How do we talk to the general public about the 20 miles difference with Hurricane Laura or the 15 miles difference in Ida, right? Those numbers are pretty staggering. You just change those storms just a little bit, or how about what Cody ran with a little bit bigger storm, putting 3 foot more feet of water on your levee. That's catastrophic. I mean, there's already a little water up to the top. This would be a mess. A little bigger. And typically when they slow down, they get bigger. Right? So a little bit bigger would have done that. So these things are razor sharp. Yep. Yes, sir.
So as public information officer for the sheriff's office, I can directly relate to how difficult it is to message, especially, talking about categories. It's nearly impossible. And I don't think we're going to change people's minds in that mindset of, oh, it's a category one, I'll be all right. Having been a PIO for 17 years now and countless hurricanes, I think that's just ingrained if that's the way people are going to think. But to your point, I think that using the plain talk in those messaging points is the key. The use of the word catastrophic damage, I don't think anybody really, that doesn't mean anything to the general public. I think that, to your point, using a word like unsurvivable storm surge is way more impressive and is going to catch people's attention. You're talking about an aha moment. For me, it was on Saturday, the day before the storm, after sending my family off. I'm sitting there in my office in Cutoff, and I hear the governor's press conference, and I forgot who it was, but someone from the National Weather Service mentions the term life-altering storm. That's the thing that has stuck out in my mind, and to me, that was a great term, a great soundbite, and probably got through to a lot of other people, got through to me, but it came the day before the storm. And if we could have had plain talk like that, on the Friday or even the Thursday the day before, I think that would have gone a long way in helping people make their decision. Yeah,
it's important that point about words matter. If people hear things so often, like the catastrophic, that's kind of we do hear that a lot, and that's why Robbie, you can talk about this a lot better than I can. We currently have 9 social science projects going on at the same time. We're looking at the cone, we're looking at our entire website, we're looking at how people interpret 20%. That's not even easy, right? What does 20% mean? What's 20% chance of rain in Lafourche Parish in July mean to you? Business as usual. But what is 20% chance of overtopping your levee mean to you?
Well, can we ask you a question? So when you heard us use life-altering and unsurvivable, it changed your perception of the storm. But did it change how you messaged the storm?
Not necessarily me, because I've been doing this for a while, but I can see your point. I mean, I can see where someone may have taken it more seriously, or it may have affected people who are doing in that role, yeah.
So taking it one step further, what would we have to do to enable someone like you to change the messaging?
I think in the conference calls, in the conference calls with the National Weather Service, I think, we go through the weather briefing really quick and we kind of just go through all the slides, but I think on that note, as again, just words catastrophic, I think we just kind of throw those around a lot. To your point, when we have a flash flood warning, we can all admit that. We don't take it as seriously as we would as if we had a Category 4, even if the impacts could be the same, because it's just not what we ramp up for. We ramp up for a hurricane. So I think if we're talking more plainly, and not just regurgitating the talking points. Like I think talking in more plain speak is how we get across, not just to the public, but even to emergency officials.
I think his question would be more because your job is to communicate to me, get it out. How do you take his words and
What would we have to do
how would you take his
to arm,
words to get it to me?
enable, give you confidence to power through that plain language?
I think the confidence level is the key. I think on the local level, we're hesitant to say anything because we know that we don't know how high the confidence level is on your end. What I will say is in recent years, I have seen the confidence in the forecast change. And this storm, I noticed that the confidence, one of the last slides that we always see, the confidence level stayed on the higher end for this. So I was a lot more confident in sending, relaying those messages out because I saw that y'all were confident. But even in Zeta and some of the storms in the past, that confidence level was midway, sometimes even like closer to a third of the way up. So it made me take a step back. So honestly, I've been looking at that a lot more in recent years because I've seen it pop up.
So it's, I mean, the lesson for us, and you guys got some take-homes, we got to have some take-homes too, is you're looking to us not just to provide you leadership on the forecast and the hazards, but you're looking to us to provide leadership on the cadence of how to sort of march up the hill, if you will. It's just too soon. It's too soon to get on that soapbox because it's too much uncertainty, or let's go ahead and get on the soapbox because there is certainty. So I think that's our take home from this.
I will add that we often don't go to that level of wording until the final 12 to 24 hours because we don't have the confidence 2 and 3 days out with the intensity forecast to be able to do that. So that's why you see it as it gets closer. Because again, we don't want to use that when
It doesn't happen.
I can count on one hand the number of storms I've used catastrophic to describe the wind damage potential. We've had a lot of catastrophic storms hit this country. Maybe there's some desensitization to those types of words because we've been hit by 7 major hurricanes in the last 4 years, and that's a different type of messaging challenge that we all have to deal with, especially here in Louisiana where it's been so frequent. But those words are chosen carefully and aren't just thrown around.
Another thing is, it depends on what time in the time frame of the hurricane season.
Right. The first storm is the 8th storm.
We evacuate just so many times. Right. If you get mild hurricanes at the beginning, they'll stay around. But that big one at the end is when it's going to get them. How do you word that in? I mean, you come out all kinds of catastrophic terms in the hurricane. People leave, they come out, oh man, this was done. They come out, and it's called the rules, they call the food, you own the road, you have to move your family. It's an expensive property.
It is.
That's why a lot of people stay there. They can't afford to get back.
Yep. Yep.
Their lives either.
Yeah. They're trapped in that, caught in that. Yep.
This is one observation. I felt we had a lot of evacuation from Katrina in this area, and also for Windell, we're doing terrible.
Yeah.
Coastal storm. And yet, this storm, that again, I thought y'all said it pretty strong because I took it pretty strong. And I really read what y'all said. I know what y'all don't sound too confident, but for Ida, y'all sound confident. And anybody I talked to, I told, get out. This storm is bigger as long as you can. But it is. Again, I'm just saying that there's something else that's different from the Katrina, Windell time and what we have tonight.
Yeah, and I don't think it helps that we've had so many storms. And the other thing, to your point, that you didn't mention, put a pandemic on top of this. That complicates things where people don't want to be sitting in a shelter. I mean, we had to deal with these record seasons in a pandemic. Us too. I said at the beginning, there's 9 hurricane specialists at the Hurricane Center. We took drastic measures to make sure I didn't lose them in 2020 and 2021. We put tape on the ground. Nobody was allowed to cross that line and get close to that person. We did. If I lose them, then there's a big impact to the hurricane. By the way, we're responsible for 28 countries. It's not just the U.S. I don't know if everyone knows that. We're responsible for the hurricane forecasting for 28 countries. So you can't lose them. So we did that. Shift changes were done from the parking lot in. We had cohort scheduling, pairs of twos. If I lose two, whew, not good, but we got some more type of thing. But if I lost half of them, that would impact things pretty bad. So we had the most named storms that we've ever had in 2020. We've only run out of names 3 times. Can you name the years?
Last year.
2020. 2021. One more. 2005. We've only run out of names 3 times. 2 of those were in a pandemic. It's interesting. So you add that on top of your comments, or yes. I mean, you got all these decisions about sheltering, and I do want to make one point. Jamie will be proud of me for this. It's about the evacuation decisions, but there's a lot of cases it's also about evacuating, but also not evacuating. We have storms where the better we could do with that forecast, the more information we get out there, the confidence in the forecast, we can also prevent evacuations in places that don't need to evacuate. The more we can refine that forecast, the better, because people that evacuate and spend that money, and if nothing happens in their mind, they're not going again. So all these factors really go into us really striving to continue to be as accurate as possible.
Where's Earl? Where's Earl?
Huh?
Where's Earl? Remember the day when we used to take the category elevated by 1 and go get the slosh mom and basically evacuate the entire coast of Louisiana? It wasn't that long ago. And now look at, we're doing this highly targeted, highly refined. I mean, it's still painful. I mean, I'm not trying to say it's great, but there used to be a day when it was, do you remember Rita? Who remembers Rita? Do you remember the people sitting in
the wind or
cars for how many lines? I mean, for how many hours? Because of the over-evacuations.
I gotta get me one of these.
You know,
I'll just go through these.
You know, context matters in terms of what we're accomplishing collectively together.
Huh? I'll do both. Now that we have power, can I just go through a couple of these? There's only like 3 or 4. I want you to see the picture. This is the Laura 20 miles example. The colors on the map is your change in your storm surge. The darkest red is 10 to 15 feet higher with moving the storm 20 miles to the west. The orange, I don't know what that is. Orange, pink, 5 to 10, and then definitely the orange is 3 to 5. So the more orange and red, the more the storm surge change. Just by moving 20 miles to the west, that's incredible. Remember the area, 35 to 40 miles, good forecast. If we're off by 20 miles a day ahead of time, scientifically it's a good forecast.
And how many feet would have been to Lake Charles at that time?
Lake Charles, in this case, 5 to 10 feet higher in Lake Charles. In the immediate coast, you got some places 10 to 15. So 5 to 10 more feet of storm surge in the city of Lake Charles. It's staggering. 20 miles. This is the example of Ida, the little wiggles. There's your 12-hour forecast, and there's your 24-hour forecast. So on the coast, 12 hours, 24-hour forecast. Out ahead of it, close to Baton Rouge. That's what actually happened. Eye test, better, worse, better, worse. It didn't move that much. It's a good forecast, 24 miles out, right? But look how the center moves and the outer band there. You see the color outside of that? Oh, I have a pointer. Outside of here, think about that being your hurricane force winds. Look what happens when I go back and forth. If you're here, you're thinking I'm okay. The little wiggle can change that, and all of a sudden you're in some of those hurricane force winds. Yes, and Mike's point is this is important right here. You can't be surprised getting hurricane force winds if you're in a hurricane warning. We put those warnings out for a reason. Does that make sense? So we can't narrow things down to just one center point, one track. It's a swath. The hurricane warning's there for a reason, because the potential is there to get hurricane force winds, trying to account for some of this movement, trying to account for some of those bands. Oh, you all are so smart. So this is the other part of the little wiggles. This is the 15-mile Ida example. So that's the Ida track. Here's the hypothetical track, 15 miles to the east. This is the change in the storm surge. You can see some of these values here. The orange, 3 to 5 feet higher. The red here, 5 to 7 feet higher. Water levels with that little wiggle, 15 miles to the east, water levels 5 to 7 feet higher along the New Orleans West Bank levee. In this case, you would have had some overtopping. Not much. The pink outside of here, this is where you have areas of inside the levee system. Cody's the expert on this.
Right. Yeah, so we just highlighted the pink to represent overtopping of levees, at least simulated.
Just 15 miles. And I did want to show, Cody worked so hard on this one. Talk us through this one too.
Yeah, so we just did this one pretty quickly, but we did the same track as Ida took. We just, a bit bigger, larger, about 5 miles actually, just bigger, and that shows you the change in inundation. So the yellow represents 1 to 3, the orange is, I think, is 3 to 5 feet.
3 to 5.
Yeah. So you can see you have greater amount of inundation, or more water on the northern side of the levee there, and even on the southern end you have additional 1 to 3 feet.
So you.
The yellow is 1 to 3, orange is 3 to 5.
More.
One more. So yeah, greater, 1 to 3.
So take your debris line and add that on top of it, on the levee. Hmm?
I was just curious, do people understand why a bigger storm causes more storms? So the analogy we like to use is like, let's say you had a bathtub full of water, and you took your finger and ran it through the water. You're not just moving much water, right? Now take your entire arm. And that's kind of the analogy of the size of the storm. Taking your fingers like a tighter, smaller storm. But as the storm grows, if you're using your arm, you're just pushing a lot more water around. And so you get that. And it doesn't matter how much stronger the storm is in a lot of cases. It doesn't have to be 1, 2, 3, 4. Just making it bigger, you're pushing more water around.
The Florence example.
One thing I'll add is we weren't very far away from this scenario happening. If you look at the radar of Ida as it was making landfall, you can see it was starting to go through an eyewall replacement cycle where the storm starts to get bigger. If it had undergone that rapid strengthening 12 hours earlier, it probably would have ended up going
That's the other presentation.
through an eyewall cycle before landfall, and you could have seen that happen. So here's the radar. Whoops. Let's go for Steve.
Oh.
He uses it.
Hmm.
You take my word for it. Sorry about that. But the point is that was a very realistic scenario, and that's in the storm surge information we provide accounts for that uncertainty. We're looking not just at, as Ken said, changes in track, we're looking at changes in size, because we don't even forecast that kind of change. We don't forecast how big the radius of maximum winds is. We can barely observe it most of the time. So we're trying to account for things that are very difficult to observe or just forecast out, say 2 or 3 days in advance. Those eyewall cycles we see are very difficult to forecast.
You're saying you could not have predicted if it would have transitioned earlier as proportion goes and made it a big storm.
Correct. It could have very easily have strengthened 12 hours sooner and gone through an eyewall cycle before landfall. It might have brought the peak winds down a little bit, but it would have made the storm bigger, and you would have ended up with that.
You would have got your additional storm surge. Yep. Any other thoughts, questions? Yes, sir?
I was just wondering, I think Cody said, in looking at if the track would have shifted a little bit and you were showing overtopping of certain levee systems.
Right.
Are y'all updating your, the height of the levee systems? Are you getting new data from all the levee systems or from CPRA every year right before hurricane season?
The updates we usually use are what's in the National Levee Database. So whatever the Army Corps has provided us there is what we use.
Yes, ma'am.
Yeah, so I'm a social scientist with the Army Corps of Engineers Levee Safety Center.
Awesome.
And so I think the conversation about the words that we use is so fascinating. And I'd be curious to hear, I know you mentioned you have 9 social science projects ongoing, but even whether it's that or just anecdotally, what words have you found spur people to action? What works well, what doesn't? And I ask also because the goal is not just to use like scary words for the sake of scaring people, it's to spur
To calm people.
to action one way or the other.
Yeah.
So I'd love to.
And sometimes to calm things down a little. Yeah.
Right.
Yeah.
Yeah, well, I mean, I think we already talked about the unsurvivable word that was used before. And that worked because it wasn't a word that's been used before. In fact, some may have argued that it was made up. Because I don't think it was in the dictionary at the time. But it got people's attention. And yes, it was only within a day of the landfall. So, but it was used at a time when we had already put out all of our other messaging. And we needed one last push. And that was the time to do it. I think as somebody else mentioned, it's not something we're going to probably do 2-3 days before, because the confidence isn't there. When you're seeing people not leaving, you need that extra spoon to get people out. I wouldn't say we have a specific study on those words that we're using, although I will say that one thing that's being looked at is that all the probabilistic language and numbers that we're using, scientists are looking at the words we assign to, say, 50%. What does a word you would assign to 50%? If I said there's a 50% chance of rain, would you say it's likely, it's possible, it's probable? What's been shown is that there's a wide range of interpretations of 50%. And so I think what we have to do, and what you guys probably need to do too, is that don't just throw words out there, likely, possible. Define what you actually mean. Because everyone has different context for what those numbers mean. So I think what we're going to be trying to do going forward is, yes, we're going to use the numbers, we're probably still going to use words, but use them together. Because then it provides the context that people need to make the decisions.
Build on that. I think the one thing you can, since you're Army Corps, you can take back, because it might be relevant, is what social science is saying is contrary to what hardcore engineers and physical scientists think. The data shows that people make better decisions and are more confident in a forecast that is portrayed to them probabilistic. And scientists can't accept that. But the data absolutely proves it. That if you can convey the risk probabilistically, you don't want to use big fancy statistical terms. You want to use plain language, but information conveyed probabilistically has better trust and better compliance than so-called deterministic solutions.
I just add too that I think we've gotten a lot better at being consistent, both with our weather forecast offices and us, to use some similar language. So we now have a decision support coordinator that is helping us there. They're helping coordinate our forecast with the local offices. Up until the pandemic, that person was there at NHC in person. But again, that help to coordinate is just to get that message succinct. And then I think that also helps really with getting people to act. And the unsurvivable warning was just the day we did that. It was just, I don't think we really all remember exactly how that came about. But it was literally, I was sitting there doing the forecast, and it was to the point where it was like, I told to Mike, I was like, what word, when Mike and I were talking, what word can we use that'll elicit just the right response? This is the time to use it. And I think Mike and Jamie went off and started talking, and that was the word that was chosen, and we used it.
It's an actual word.
It is now.
No, it is. It's an old English word, so it's not used commonly now.
I don't think that's what Webster's It's not in the modern dictionary. It's a little
But I think Merriam-Webster is based off that, they're going to put it in the dictionary. Anyway.
What did the Hurricane Center?
Oh man, it's just great.
Do you think, I mean, this might be a question for you, I guess, social science, but do you think that it depends on, your messaging depends on what region you're talking to? Like, for example, do you think someone from that area is just going to interpret and forecast differently than someone from
Yeah, who wants to take? The answer is yes.
If you're briefing someone in New York City,
It's all different.
it's totally different than if you're briefing someone in, say, Texas. But yeah.
Yeah, I mean, it's different between what they've experienced, culture, language. You know, we're serving a national and international audience, so we have to choose our messaging and wording carefully for that wide variety of people. But yeah, I mean, you would certainly message a major hurricane approaching the Northeast differently than you would approaching Louisiana, both for familiarity. You might not even assume people understand basic terms or basic words that might be very well understood or commonplace in an area that's more frequently affected by significant storms. So, you know, that definitely comes into play. And understanding the culture and history of an area, that's where the local WFO comes in, because they're really tied into that community and they understand what the recent history is, what the experiences have been in that local area. You know, areas that have had near misses or hits recently, so that all has to come into play in the time message. So it's a real team effort to get that correct.
I ran with
It's not
it.
easy.
I just
And
ran with
It's
it.
not just us, it's our partners in the media,
I know.
it's the partners in the emergency management, government, community making the decision.
Ken,
And
just
just-
one thing. So when they did the hurricane transportation study for our area, they put some pictures in there of what level storm surge would look like in different areas of the parish. And when local people see what 9 foot of water means, like at Rhome, they can vision that and view that. And we use that against our levees, the floodgates. We took some pictures and said, 9 feet of water on the outside of this floodgate, this is what it looks like. And they understand that.
Yeah.
They understand that. And the other thing was, you know, and I know we didn't talk about research, but there's a 90% chance that those values will be exceeded, right? So
No, the other way around.
It's the other way around.
Yeah.
That it won't be exceeded.
Yep.
Okay. So I've told people all the time was, if you had a 50% chance that those numbers would be exceeded, would you cross a railroad track today if you knew 50%? You had a 50% chance of getting hit today. If somebody told you that, would you cross that railroad track today? You probably would.
Yep.
You'd probably go around. So I tell people when those numbers come out, you gotta leave. Because there's a great chance that it's gonna hit those numbers. But you're right, you gotta put it in a perspective to where people can vision that.
And it's the pictures, or what Earl's saying, that the pictures, what's the old saying, worth 1,000 words, whatever it is. And that's why when we talk about storm surge, sometimes I'm 6'5", so I try to equate storm surge to me. But we try that just an attempt to try to visualize something. But those pictures mean so much, just to be able to visualize what that looks like. Look, my daughters, if you don't communicate in 15 seconds on TikTok, they're not going to get the information. Well, it's real. So, I mean, they wouldn't touch Facebook with a 10-foot surge pole because it's only for old people. So how do you communicate with the next generation coming up? Then it was Instagram, and then I'm missing a few, but Snapchat. But my kids, it's all about TikTok. And you got 15 seconds to get your message out, or they're moving on to the cat that sings a song or something.
So on that, the emergency management officers, we have 2 people that are a lot younger than me that's pushing out social media almost 24 hours a day, because that's the only way people are getting their information.
Yeah.
But the problem with that is the older generation is not getting the
That's right. That's right.
So Earl, your comment about visualization is a good one. And it's timely because we're all sitting around trying to envision the next generation system, design it, and figure it out. But the comment about visualizing, that was one of the primary reasons we switched to conveying storm surge above NAVD88. And how many of you know what NAVD88 is?
This is a smart group here.
How many of your constituents know what NAVD88 is? Right. To above ground level, so that you can say, Ken can say, I stand 6'5" above ground level, right? Storm surge will be up over your rooftop because it was a way to
visualize,
make it more palatable, stomachable for people. So, I know there's some data lovers amongst this audience, and that's great when we're talking amongst each other. When you're trying to convey information to the general public, that above ground level is really, really important because it helps you to, my roof is what, 8 or 9 feet, right?
Useful today? You got a question?
Oh, yeah, just 2 things.
Yep.
One was to compliment you guys. I follow during, like she was saying, we become storm experts when a storm's coming. I follow Stormcast forums, and they are very critical of everyone, but they have given you guys accolades about how well y'all have been doing. So I don't comment, I read, I'm a lurker, but they have, and that is from following them for a few years. That's a really big compliment, so I want to jump in.
Yeah.
People have to go out there and think very highly of your company. Secondly, I would say your messaging has been on point, but the messaging I think is missing with the meteorologists. And I had there's one guy I follow that I really find to be very accurate. And everything he says is going to happen to storm coming. Meanwhile, a family of mine, a member, watches a different meteorologist and is telling him something completely different. I'm going, oh, no. Do not listen to this person. You need to listen. So the messaging between meteorologists and stations is critical because that is who the older people listen to. That's who I listen to. I use Twitter, whatever, you guys, but not everyone's going to National Hurricane. So they're relying on their local person that they see their face every day. And that messaging amongst them needs to be a little bit more consistent.
Yeah, and I think part of it is we try to get aggressive on it's not just your national networks, we're pretty aggressive on some of the local networks during the heat of the battle too, so we can just continue to try to drive some of that messaging to try to help out. But yeah, I would make one positive comment about that. I think it was worse 10 years ago. Well, I really do think it was worse. I think allowing government people to be able to jump on social media and to do different things that we have, I think we've not accidentally, because we were consciously trying to do that. I think it's made a difference in getting our information out, having further accessibility of our information. I think that still could occur, but I think in the last 10 years, I think it's getting a little better anyway, but yeah, that happens.
I think the meetings that y'all have with the media and the emergency managers kind of helps that.
Yeah.
Like I said, we've been doing that for 10 years now.
The integrated warning team, the IWT.
Yeah, and I think they get a perspective of what we're dealing with, and we know what they're dealing with, and you guys are in there, letting them know, what's available for them to make sure that we have a common message and what's come out of it.
If you get a chance, go to one of those. They're fascinating, even from a social science perspective, because when you get emergency managers, you get weather service, and you get media in the room, everybody put your Twitter away. Whatever happens in here, let's be honest, talk type of thing. It's wonderful. It's wonderful because you can educate the others on what you do for a living and go, wow, I never considered that you had those issues. I didn't know you had to send out an hourly social media message. That can't be easy type of thing. The pressures that others are under, and those type of meetings are incredible. And this is too, right? And I appreciated your first comment, thank you. But the other part is that the sincerity is there. We share all of our error data, we share everything. There's nothing to hide, why would we? But it's one of these things that we're here having these meetings. These need to happen more frequently across the whole country. Not just with hurricanes, but fire, tornado, everything else, just to have the real conversation, to have a science conversation that's converted to social science because we're really trying to influence the decisions. These are priceless. So I hope you all found this useful. Yeah.
How many of these do y'all have for this time of year?
So we have a lot of conferences we go to. This presentation that I gave, I'll do at the National Hurricane Conference. Mike will do the summaries plus this. I mean, there's all sorts of presentations that we give. The local weather forecast offices, WFOs, they really get into the community. They really do. Some of your kickoff meetings, how many times, or all over the years. I mean, they really, the local office will be able to give a lot of these type of things. We try to get where we can. Yeah.
But I mean, we took a major storm.
Yeah.
Y'all were right, we got it. But it's the places like this year in St. Bernard who didn't get the major hit. We might think they got the major hit.
Yeah.
We need to talk to those people, have a meeting like this for those people as well.
Yeah, the local office, I think that they're still at all the kickoff meetings. So the parishes have their kickoff meetings, and the weather they're there giving these same messages. So we hit, if we're not there, the local weather forecast offices, they'll be there. Yeah, so every year we had a kickoff, and we talked about these things. Eat a little food, talk about hurricanes, doing that for a long time. Yeah, and the IWTs as well really gets into some of this stuff.
Yeah. Surge hits against hard structures, but it seems like, for me in the past, I always thought that ramp up was in the order of 2 to 3 feet, but I guess it depends on the size of the storm, the speed, the velocity.
So that was, to be clear, the 10 feet was observed. We estimate the surge to be higher than that based off our post-modeling, some of the modeling Fritz was talking about. So like on the Grand Isle, it's probably closer, maybe a little higher. We're still going through the evaluations now. Here around Golden Meadow, a little bit maybe more here. And then you always get a localized run-up on the face of the lake. Okay, so there's always going to be a little bit, the debris line's going to shoot a little bit beyond the still water elevation. So when we're saying we think the surge is 10, 11, 12 feet, we're talking about still water, not so much the runout. We handle the runout differently.
Talking about surge, just a question on my end. What is your average elevation of ground level whenever you're talking about surge?
We're fortunate here in Louisiana, or you're fortunate here in Louisiana. We have incredibly high resolution information on topography, 3-meter resolution, so that's about 10 feet. So I mean, you can basically see every ditch there is. So it's, not every state has that good of elevation.
Because y'all moved down to the shelf today. Okay. So underneath our operations center, we had 6 feet, and that's at a +4 elevation.
Right. Okay. Right. So it tells you there. It's a +4 NAVD8. So you add them up. That's 10 feet NAVD88. Again, we're still cranking through the numbers to see what we're getting, but I'm going to guess we're going to probably be 10 to 12 feet. 6 to 12. 6 to 12 feet. But when Mike was saying 10, he was saying the peak observed. And just like wind, the peak surge can be difficult to measure, especially if it's at the face of a levee. There's no observation there, and so you can only do it, reverse engineer it from the debris line.
We always see higher elevation of water up against the levee than we do along the coast. In other storms too, that's happened. But I mean, on this particular storm, there was a lot more run up.
Yeah, there's a lot there. I mean, we're seeing that in our post-storm modeling. There's a lot of wave action in this particular storm. It's too soon to know what the root cause is, other than really strong storm.
It all depends on the angle of the wind and where
Oh, yeah.
it's coming from. And because you had areas along the Bayou Lafourche that might have had, that might be at a +5 elevation, and they only had a foot of water over that area. But other areas that are at a +5 elevation had, 5 feet of water on top. It's just depends where it comes from.
Yeah, surge is
Yeah.
surge is like real estate, location, 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 and that's what makes communicating it so freaking hard because all your constituents now think they got whatever feet of storm surge, right? You got people that probably got 2 feet, they could get 20. And so the next time you say 20 feet, you're, oh, no, it's because it's so tricky.
That's good.
A question. Are there enough observation points?
That's yours.
Because I know if you think about it, like the airport in Galliano is like one wind gauge in this area. I think there might be like a wind gauge in Grand Isle, Homa Airport. In this area, it's kind of scattered, so it's kind of, I guess, pinpoint where such and such wind might be observed. It's almost kind of like you kind of are kind of splitting, kind of trying to figure out, are there enough observation points, or maybe y'all looking to add more?
There are never enough observation points for a scientist point of view, but that's scientist perspective. But to your point,
It's true.
We're looking to the future. It's going to be more deployable.
Yeah.
So you don't necessarily, you put the sensor out in front of it and then go recover it after the fact. And it's going to be cheaper long term to do that.
Yeah, especially for like finding out water elevations and all on like what was on the levee, instead of trying to guesstimate. You actually either like a photograph or some sort of like visual evidence of, hey, the water was this high at this point in the storm. Because actually, we have a camera for the storm, and it's been there probably, I think, since 2008. That's piped all the way from Windell, the foot of Windell system at the Floodgate and Golden Meadow. It goes all the way into our studio, and we can actually see what it actually looks like as a video that's at Windell system. So that's one thing that we enjoy over here, that we get to see. Hey, as long as the telecommunications still work, because it's hooked up via fiber, and we were actually seeing the water come up almost to the top of the cement part of Windell's system from our studio at home, and we were streaming it live on the internet and all too. So, and we outside a camera that's at the multiplex building on Grand Isle that was sending video throughout the entire storm up until we lost telecommunications with that too. So.
That sort of stuff is becoming increasingly valuable. There's a lot of local governments that are installing their own instruments or webcams and that sort of stuff, and we're trying to bring that in as best we can. The challenge is everybody's on a different platform, a website, and it can get overwhelming to take it all in. So it absolutely helps in the post-storm reconstruction. The other thing we're doing more and more of is storm surge. Our storm surge model, Spot, has gotten so good over the years, we can now run it in sort of a forensic perspective and recreate what happened and using the observations that we do have as sort of a calibration. So we run it we probably run it 10, 15 times since the storm to try to make sure we hit the observations. And once you hit the observations, you've got a very high detail analysis of what happened.
Windell, do we miss anything?
Well, I'm glad you mentioned this a lot. I've been working in Austin since 1985, and I thought the people had some, because they know that there's so detailed with so much information, but I've talked to people that said basically very hard to just answer because it's so rigid. It's off a little bit, it's off a lot.
So I'm gonna use the recommendation for plain language here. How many of you have gone out and and gotten the latest and greatest piece of technology, the latest phone, the latest whatever, reluctantly, and it wasn't reliable. Slosh has been around for a long time, and that's not its weakness, that is its strength. How many of you work on old engines or carburetors? And when it breaks down, you know exactly where to touch it to make it fire. That's slosh. It's been with us so long, it's so reliable, it's so dependable, and in a crisis, you want a phone that works, not a phone that has the latest gadget. That make sense?
I didn't talk the same thing. Well, you get a lot more detail about it, information, but that extra detail really doesn't help the big picture.
Well, the other thing.
Just because it's more doesn't mean it's better.
Right. Well, the other thing is when you evacuate, you go through and say, this house, yes, that house, no. No, you evacuate a community. You evacuate a zone, right? An area, a city.
A shotgun effect.
Right.
I think a lot of things with hurricanes is a shotgun effect. It's not right.
It's-
never right.
So,
The probability.
It's the probabilistic too.
right. And so
Yeah.
slosh is also incredibly brisk, fast, it's efficient. That enables us in the amount of time that it takes other models to make one simulation, we can make thousands. And from those thousands, we can back out all sorts of things like what if it goes over here, what if it goes over there, what if it's stronger, what if it's bigger, what if it comes at high tide, what if it comes at low tide. And we can pull out the actual risk, the true risk. And so if you call me in the middle of a storm, what's the probability of my levee overtopping? I can tell you. And it's a very powerful decision-making tool. If I tell you there's a 50% chance of your levee overtopping versus a 5% chance of your, it's a totally different, right, think about that as a decision maker versus, well, if the hurricane goes right there, it overtops. I have no idea what happens if it goes over there. You see it.
I actually do that. It's just about, I have all maps of the models, maximum, and when I look at the storm, I know you can do this, this, or this, well, the models gotta go. They would use those old maps to make fun.
It's wrong to assume that because slosh is old, it's bad.
Yeah. There's why.
You using LiDAR?
Oh yeah, we love LiDAR. We eat that stuff up.
We did the first.
That's why we use slosh. That's why we use slosh. It is good.
Yeah, we love that stuff. We're big data diligence.
The first
Hmm? You gotta build this pit this high.
Input matter.
Question.
So over the last 2 years, it seems like a phrase that we've heard repetitively is record, especially after Hurricane Ida. So were there any, over the last 2 years, key takeaways or lessons learned for y'all? And then what are the key takeaways for us going forward as we inch closer to another hurricane season in 4 months?
I'm going to do something a little unusual, and you know, it's really the lessons learned for us. I'm going to pass it to each person, so start thinking about your lesson learned. You know, I think one of the lessons learned for me, record-breaking 2020. I mean, you look at last year and during a pandemic. I think as Hurricane Center director, the big takeaway for me is, you know, you got to have a you got to have a plan and take care of these folks. That could be ranging from feeding the zoo during a hurricane, you know, or we, you know, during this pandemic, we wrote a plan to keep ourselves safe, and I think the communication is my big takeaway. You got to keep talking. We had about 180 meetings talking about COVID safety. We had I think we're up to about 128 all-hands meetings where we talked, we communicated, we checked on each other. How you doing? If you got a problem, you better call or text me in the middle of the night. So my takeaway is, you know, every hurricane's ours, 28 countries. And that takes a toll. We don't talk about it much. They may or may not talk about it, but that's a stressful toll to have that many hurricanes in that period of time. Sometimes we're beat up too. So the lesson for me as Hurricane Center Director is I would do anything for this bunch. Yep.
I think thinking back to the types of storms and all the different scenarios we've encountered, not just in the last 2 years, but maybe the last 4 or 5 years, I think I realized how important it is to be flexible and be nimble in our approach to communicating and to really being fast and able to respond to different situations as we see them. We talked about earlier how, an Ida 5 years ago, we probably wouldn't have made that forecast initially. But we have to trust ourselves and be confident in the guidance and in our own experience that we've gained during this period of time to be able to go out on that limb when it's called for, because that really is going out on the limb. Dan's standing out there, you hear the limb start to crack sometimes when you make a forecast like that, because it really is. It's really unnerving. And I think we've learned to be confident in our instincts and trust what we see and to not be afraid to be bold when it's called for. And that goes to messaging, it goes to communication, it goes to the forecast. And I think it's only been more and more reinforced over the past few years that the forecast is just the beginning of the process. Everything's foundational on the forecast, but it's really about so much more than that. It's really about the hazards and the communication of that information, sort of closing the loop from the science and through the social science to the products, to the decision makers, to the public. And that's really a loop we have to continually make sure that we close, because we can make the perfect forecast, but if nothing happens on the ground and people stay where they shouldn't be, then what good is it? So I think that's probably the biggest thing I've taken away after the last few seasons.
I just want to convey, building on Mike, how much we appreciate being here, being isolated in our cocoon for the last 2 years, while also being scrutinized under a microscope, took its toll on people. And the opportunity to get out and hear our work matters to this significance starts to restore the soul and bring back what the last 2 years took away. So that's my takeaway. The other one is we've always known you look to us to provide leadership from a hurricane forecasting perspective, but it also seems from a messaging perspective too. You're looking to us to sort of set the tone from a conveyance of confidence as well. That's a big takeaway.
I would say for me, over the last 2 seasons, one of the reasons why we started showing more images like this, because during the 2020 season, even from fellow scientists, they could not even understand where the storm surge actually occurred, or would say that it didn't occur because they couldn't see it. But we obviously knew that there was a lot of storm surge somewhere. We knew where it was, but it seemed like for a lot of people they didn't understand where that was. And so for me, starting to do things like this to make the message more effective, communicate, not just to you guys or anything like that, but even some of our fellow scientists who can't understand storm surge and how different just a few miles can make. That's really something that, for me, I want to be better at, communicate more effectively. How just little changes can really make a dramatic difference.
So I'm going to turn it the other way a little bit here and say that hurricanes are always going to be bad. They're tough to deal with. Anxiety can drive anxiety, but if you take a step back and look at perspective of where we've come over the past 5, 10, 15 years, I mean, we at the Hurricane Center, you guys, we've actually gone pretty far and improved things in leaps and bounds. And when I started the Hurricane Specialist Unit in 2008, Hurricane Ike, and I think about when it hit Texas and what we were actually providing at the time. And it was like this compared to what we provide now. You can go to Katrina. We didn't have storm surge warnings. We couldn't tell exactly which areas are going to get flooded with this sort of technology that we have now. I mean, I think as a community we're doing a really good job, and I think the fact that the number of deaths, even though we still have deaths we have to deal with, the fact that it has gone down and we're now turning to indirect deaths as a concern speaks volumes. So I think we all need to be applauding ourselves for how far we've come just in the past 10, 15 years.
I'll just add a little bit onto that, kind of similar to what Robbie said. I started in a unit back in 2006, but just a couple years before Robbie. But I was been at the Hurricane Center a little bit longer than that. But it's just one thing I think I've learned a lot in the last really 5 years is we've unfortunately we've gotten a lot of practice at putting out these forecasts, these messages, and I think it's built confidence in the forecasters to make forecasts like we did. And I think there's a lot of knowledge gained that we can use to go forward because of that experience that we've had. And it's unfortunate that we've seen that, but it is true that I think we've really gotten better there. The messaging is so incredibly important. I think we've all realized that, but I think in the last 5 or 6 years with social media, now that we can be a bigger part of getting that message out, I think it's really also been a big focus of ours to do that. So I think that's the two biggest things. One thing I think I've learned from you all, especially this past year, one is I know you've been incredibly busy, hurricanes, pandemic, and everything, but just understanding your timelines. And what, I think about it a lot. What can we do to provide you more and better information sooner so that we can help you with those timelines? Because that's where I think we got to be thinking for the future. And I know it's a difficult task, what you all have to do, but IDA is not the worst case scenario for something forming, strengthening, and making landfall. It's just not. I put together a presentation for National Hurricane Conference, and I know it was in the Caribbean, but you go back to Maria before it hit Dominica and Eastern Caribbean. It essentially formed and became a Category 5 in 2 days and made landfall. So it can happen. I hope it doesn't. I hope it's a long time, but it can certainly happen.
Yep. Did that? Okay.
I just want to mention, that's important for me. That's probably what has happened in the past. That doesn't have to happen where I'm at. There's so much. Mitch, 4 or 5 days vacillating from category 4 to 5 and seeing isolated off the coast of Honduras in Guatemala. 10,000 people killed. That's real. That's a terrible nightmare off of this coast. But truly, the landscape absolutely changed if you have that type of situation. But that's a possibility. See, John said it here. I try to get people to understand that bad things in the past have happened to our community, and not just a few years ago, but we've been kind of successful the last 45 years. But we had 4 to 5 feet of water, or probably 40% inside of our levee system in 1985. And since 1985, you have people that are growing up and have kids, So we try to remind them that that's a reality that can't happen. And again, using even Bangladesh, to think that we lose 125,000 people in a typhoon. And we don't hear about that over here. We don't talk about it. But our delta, we have to look that far away to find another delta that's kind of like us, that's subject to hurricanes. So I try to tie that in, and that's great information for us to use when I get to look at that type of data. To make people understand these storms can do these things, and if they do it here, the results will be better. The reality to me, when you can deal with reality, practice stuff, it's a little bit easier to bridge so one's understanding.
Yep. Any other comments, thoughts, questions?
The little joke about this, we should have had some farmers here, some old farmers, because they really are experts in some of this stuff.
They do. You're right. Too much water, not enough water, they know all about water. Yeah.
Is there any requests? So, you know, it might be good to ask some questions, that everybody else will give some questions and the answers.
Oh, sure. I just had a question. I do get this question a lot. A lot of folks ask me why it wasn't classified as a category. Well, it wasn't added IDA classified as a category 5 before. Like some people on social media in particular will say, well, my gauge.
Mike, do you want that?
170 mile an hour winds, et cetera, 200 mile an hour winds. And so just wanted to see what is this? How do you ever go back and reclassify these hurricanes, or is that count on the?
We do.
Yeah, I mean, I can start off, and Dan or Robbie or others chime in. Yeah, we go back and we do a post-analysis of every storm every season. So we go back and, you know, one thing Dan mentioned earlier, that it's you know, in the heat of the storm, you know, we have maybe just a few minutes to try to make sense of all the data that we're looking at, from the aircraft, radar, surface observations. So we have to make kind of snap decisions about, okay, we think it's 130 knots, or 140 knots, or 120 knots. You know, after the fact, we have the luxury of time to go back and look at all the data that was available in real time, plus data that we didn't have in real time, and sort of make our best post-analysis of IDA. We're still undergoing that process now. But, you know, the main data, like I said during my presentation, we didn't have any reliable, sustained wind estimates that we saw anywhere anywhere in Louisiana that were above 100 knots. So our intensity estimate is really based on what we saw in the aircraft data right up to landfall. And that's based on the aircraft winds that are measured at about 10,000 feet where the aircraft flies, and we have relationships that help us adjust those winds down to the surface. And then also data measured by what's called the step frequency microwave radiometer, or the SFMR, that measures or estimates surface winds based on the roughness of the ocean surface. And all the data we saw from that in real time suggested that IDA's intensity was around that 150 miles per hour, 130 knot category 4. So, you know, we're still looking at it for the post-analysis, and that's where we are in the process at this point. But I'll mention we upgraded Michael to a category 5 after the fact. In real time, Dan and I were there that day. We had some aircraft data that, you know, sort of difficult to interpret in real time, and we thought the best estimate at the time was 135 knots, which is category 4, 1 knot short of category 5. Remember, 10% uncertainty. So there's very little difference between 135 and 136 knots. It's imperceptible, really. But after the fact, we had radar data. We took a closer look at the aircraft data. It was reprocessed. We had a chance to look at it more holistically. We made Michael category 5 after the fact. So it's not unusual for us to adjust the intensity of a system 5 or 10 knots up or down. It's routine, in fact. So, but what we had in real time suggested IDA was a category 4.
Mike, can you make one comment? One thing I didn't appreciate when I worked at the Slidell office was it's not just the previous season, the reanalysis stuff. To make sure the scientific record is so accurate. We're looking at storms in the 70s, 60s, and everything. I never appreciated that when I worked at the local office till I got this job.
The Atlantic Basin, for all the places in the world that have tropical cyclones, the Atlantic Basin has the best database on record. It goes back to the 1850s. But you can imagine the early parts of that database are based on some ship observations, some land observations, very sparse, very uncertain. Probably missed a lot of storms. We're going back through that entire database, reanalyzing every system and looking at it in the light of what we understand about how storms behave and the data, any new data we might have come upon. So we're just in the process of getting through like the 1960s. So, you know, we're saying, oh, this storm was a little stronger, this storm was a little weaker, because we're trying to understand it and get the best database we can. So even many years later, we may find some relationship 20 years from now that changes how we interpret radar data or aircraft data or how we think storms behave that could change how we analyze the intensity of the storm that we're looking at even now. So it's never a fixed number. It's always the best state of the science. So we're always going through this trying to come up with the best record because those databases are important because they help our modeling, they help us understand what's happened in the past from storm surge or from other hazards and develop climatologies of storms and what the risk is for storms in different places. As Windell said, you know, there's plenty of things that have happened in this part of the world and elsewhere that we don't have any idea about. And certainly it was before the 1850s. We can go back and find storm surge events or evidence of significant storms hundreds of years ago. And so it's important to have that record and data base be as accurate as it can so we can understand what the past was.
I just thought you'd be interested in that because I don't think I even had an appreciation of that till I got this job.
In the post-IDA analysis, has there been any change from what you saw the day of?
We haven't finished it yet, so we haven't finished the process.
Still going.
It's still ongoing. So
It'll be done when we release the tropical cyclone report for Ida. That'll come out sometime in the next, I would assume next month or so. We try to get through the storms before the next season starts. Sometimes it's hard. In 2020, we had like
too many
60 systems, so we got them out like basically in June, but this year we didn't have quite as many, so we're moving through them pretty quickly.
Yeah.
But Ida, the storms that affect land take a lot longer. There's a lot more data to go through. We're trying to catalog all the impacts and the damage as well, so we're still working on it.
Yep. So I think hopefully that answered your question.
I have one more question. Any predictions for the next upcoming hurricane?
Huh. Yeah, so the our official forecast, I know official forecast will come out in May, but really looking at things, really looking at some of the the global patterns. As we know, we've seen at La Nina you get more storms, and we're looking at just some of the early predictions, some sort of neutral to weak La Nina. So there's no reason for me to believe that it's not going to be at least average. Is probably the best way to put it, which means we got to be ready again. But the average is new now. I don't know if you know that. It's now 14 named storms in a year now. So it's interesting when we update it. Every 10 years you look back at the last 30 years of records and you update everything from temperature to precip and everything. And looking at the last 30 years, the average went up to 14. So the average named storms actually went up. But I did want to make an important comment that with these predictions, it's all about safety. So whether we predict there's going to be 30 storms or one, the Hislop-Fouche Parish, that one on Earth is going to be a mess. So you got to be careful, because even in El Nino year, in 1992 you had Andrew. There were hardly any storms that year. That was the only major storm in 1992 because it was El Nino. And you look back, that was nothing, right? Andrew was a big deal. So even in a season you don't get a whole lot. If it gets you, it's still a bad season. So it's back to the messaging. It's back to the social science. That prediction's wonderful, but at the same time, we usually come back and say, well, it's good, but it's all about being prepared for that one. Yeah. You all think of anything else? Yes.
Interesting observation.
Okay.
Hurricane Andrew, we were talking about earlier. Dr. Oscar Hugh, first Can Lab, Baton Rouge. He was doing some work for us. And I had a picture of the eye of the storm. And I asked Dr. Hugh, I said, Dr. Hugh, the sun is shining on one side of it. Is there a difference in the temperature? So he checked. I said, hell of a lot of difference on one side of the eye to the other side of the eye. Where the sun is shining, the sun is not shining.
Yeah.
So it's quite a few degrees. Interesting.
Well, and the other takeaway, it's interesting, but it just shows you the complexity that we're dealing with. I mean, trying to forecast ahead of time and who gets what storm surge and wind and all the incredibly complex systems. And that just points to just one of the parameters that makes it tough. And you got water temperatures behind it, you got the upwelling of the cooler water behind it, so you got cool water trail back behind these systems. It's incredibly complicated. So good observation, yep. Tim Osborne, any comments?
I want to just make sure you guys show and appreciate everything they're doing. They're always there to answer questions, no matter what time, even during the storm season. We're going to get you out of here in just a minute.
Wendell, you want to wrap us up? Hey, just real quick, thank you. So, yeah, thank you. And I think it's back to your question about the lessons learned. I just want to say one thing. Let me tell you, it's meetings like this. It's the years of working with emergency management. I'll tell you the biggest word that comes to mind every time is trust. And these honest conversations really help us trust each other. So thanks for being honest. We really do appreciate that. So Wendell, thank you for the invitation, sir.
Sure.
Yep.